Today's target will be solving systems of equations using elimination. By the end of today's lesson, you will be able to identify when to use elimination to solve a system of equations, and you'll be able to use elimination to solve a system of equations for both variables. So let's start with when we do use elimination. There are three methods that you should know for solving a system. The first is graphing, the second is substitution, and the third is elimination. The best time to use elimination is when both equations are in standard form. So remember that standard form is ax plus by equals c. So for example, if you had the system 2x minus 4y equals 12 and 4x plus 3y equals 18. Both our equations are in standard form, so this is when we would want to use elimination. Exactly how do we use elimination? Similar to substitution, the goal for elimination is in the name. We want to eliminate a variable. And the way that we do that is we simply combine both equations into one. And we're going to do this either by adding or subtracting. So you'll notice with this first example here that our y variables, we have a positive 6y and a negative 6y. So if we were to add those two together, they would cancel each other out. So what we want to do is we want to basically take this second equation and we're going to add all of our like terms. So 4x plus 3x becomes 7x. 6y plus negative 6y cancels out. And then 32 plus 3 becomes 35. So in combining both equations, simply just combining all of our like terms, the y variables cancel out and we're left with one simple equation with just x, or we can divide both sides by 7 and get x is equal to 5. Now, just like with substitution, we need to go back and solve for the other variable. So to do that, we're going to take the x value we just found. I'm picking one of the two equations. It doesn't matter which one. I'm going to go ahead and use the first one. So 4x plus 6y equals to 32. I'm going to plug 5 in for x, giving me 4 times 5 plus 6y equals to 32. I'm going to go ahead and solve this equation for y. So we end up with 6y is equal to 12. Dividing both sides by 6 gives us y is equal to 2. So there's our process. First step is really simple. Second one's a little bit more work involved, but it's not overly complicated. Here's our second example. Now you'll notice if you look here, if I were to add these two together, I were to take the first equation and add it to the second, 5x plus 9x is 14x, 2y plus 2y is 4y, and 6 plus 22 is 28. Well, that doesn't help me at all because nothing canceled out, nothing was eliminated. Well, remember what I said in the first examples, we don't have to add, we could also subtract. So if we take this second equation and we subtract it from the first, 5 minus 9x is negative 4x. 2 minus 2y cancels out. And 6 minus 22 gives me negative 16. Now all my y's cancel out just like the first one. divide both sides by -4, gives me x is equal to +4. So it doesn't always have to be addition. You might have to subtract sometimes. But the goal is to either add or subtract so that one of the two variables cancels out. Both of our first examples, it's been the y that's canceled out, but it's not always going to be the y that cancels out. I need to go back and solve for y now that I have x. Doesn't matter which equation you pick. This time I'm going to use the second one. So I'm going to plug in my x value of 4, giving me 36 plus 2y equals to 22. Subtract 36 from both sides. Gives me 2y equals to -14. Divide both sides by 2. Y equals -7. And then one more example. Here, if we add these together, 5x plus 2x gives me 7x. 6y plus 3y gives me 9y. -8 plus -5 gives me -13. Well, that doesn't work. If I subtract 5x minus 2x gives me 3x. 6y minus 3y gives me 3y. And -8 minus a -5 gives me -3. Well, that doesn't work either. So in this case, neither addition nor subtraction alone is going to get us a variable that's eliminated. So in this case, we need to multiply by a number. And the reason we're going to multiply is we want to get coefficients to match up. Now remember, with an equation, we have our golden rule. Whatever you do to one side, you must do to the other. So we can do whatever we want. We can multiply by whatever we want. We could add whatever we wanted to, as long as we do it to both sides and keep our equations balanced. So what we want to do is, when we look at our x's, we'll start there. So I've got a 5x and a 2x. Is there anything I can multiply by 2x to equal 5x? No. Unless I was going to multiply by a decimal, and I really don't want to do that unless I absolutely have to. So no, there's nothing I can multiply by 2x to get 5x. Well, let's go to our y's. Anything I can multiply by 3y to get 6y? If I multiply by 2, it would. 3 times 2 gives me the 6. My coefficients would match up. Now, I can't just multiply the y by 2. I've got to have to multiply the entire equation by 2. Remember, whatever you do to one side, you have to do to the other to keep the equation balanced. So in doing this, my equation is staying balanced, not breaking any rules. So in multiplying everything by 2, I've got a new equation. Make sure you multiply everything by 2. It gives me 4x plus 6y equals -10. Now I'm going to go ahead and cross through this original one because I don't need it anymore. I now have 5x plus 6y equals -8. 4x plus 6y equals -10. Now I can go ahead and subtract 5x minus 4x gives me 1x. 6y minus 6y cancels out. -8 minus -10 gives me 2. So we see that x is equal to 2. So sometimes you have to do a little bit of manipulation to make sure that some of these numbers match up. And when you do that, you need to make sure you multiply everything in that equation by whatever number you've picked. I'm going to go ahead and take that x value of 2, plug it into my first equation. So we have 5 times 2 plus 6y equals -8. 10 plus 6y equals negative 8. 6y equals negative 18. Divide everything by 6. We get y is equal to negative 3. So you've seen 3 examples. Use those 3 examples to try to solve this system. You will have to multiply. So look at your x values, your x variables, and your y variables and see which one could you multiply to make it equal to the other. So look at the example we just did and see if you can use that example to solve this one. Pause the video now. Here's your solution. Going to have to multiply the second equation by 2 in order to make the coefficients of our x's match up. Make them both 6. Once we do that, we're going to go ahead and subtract. So we have 6x minus 6x goes in, and will cancel out. I made a little mistake here. Give me a second. I'm going to go ahead and fix that. Sorry about that one, guys. Made a little negative mistake when I subtracted. You got to watch your negatives. So we do negative 2y minus a negative 14y. You're subtracting a negative, so it's going to become addition. I forgot to do that, which is why I had negative 16y when I should have had positive 12y. So once again, negative 2 minus a negative 14y becomes negative 2 plus 14y, which gives us 12y. Same thing happens with the negative 38. 10 minus a negative 38 becomes 10 plus 38, which is how we get positive 48. Dividing both sides by 12 gives us y is equal to 4. Taking that and plugging it back into the first equation gives us 6x minus 2 times 4 equals 10. And we can solve that equation to get x equals to 3. As always, guys, if you have any questions or concerns, or there's anything I did in the video that didn't make sense, please make a note of it. So when I see you in class next time, I can help you out and clarify whatever you need.